Did you look at it in like a lot of detail?
Hopefully you're not asking questions, so.
You're ready for the quiz.
Ben was going to do that.
Did you look at it in a lot of detail or just a little?
I pretty much went through most of them.
Okay.
But there are places where I felt it was, I don't know if this is it went down into the gory details of how specific things are. There is a data flow in one of the places in extremely in a gory detail that really requires you to really look at the source code and say, okay, what file am I looking at? So just by saying the class and interface does not mean anything, then you have to do find, and it was a little bit of, I gave up after that. Right?
Okay, that's kind of what this session's about, and I've got the source code.
I thought I will get that here anyway.
How is your guide for gory detail?
I can make this as gory or non-gory as you want, maybe. But I think the goal is we want you to understand enough that you can follow code through the API service and the controller service. So first we want you to understand them conceptually, and then for a given operation we want you to be able to go to the code and say, where do I start? Where do I at least look to see how this operation might be implemented so I could implement something similar, and then how would you follow that operation kind of down through the code. So a lot of people contributed to this page. I wrote a lot of the words on this page though, and as I was writing it, I was trying to think about what does someone need as an introduction to be able to look at the code and sort of find their way around. That was the goal. So I want this to be really interactive, so feel free to stop me. Now I'm going to ask another question. How many of you have actually provisioned a volume on Copper HD or Copper HD on the One, Sal. All right. All right, so I think that says I'll start. I'll start a little on the basic side, and I'm going to go start with concepts, and then I'm going to show you the UI and show you the concepts in the UI, and then I'm going to show you this wiki page, and we're going to talk about the concepts there, and then I'm going to show you some code, and your eyes can glaze over, and we'll try and tie all this together. And I hope I'm successful. So please tell me if I get off the track or in too much detail on a particular area.
It's a 3-hour-and-a-half block of time. But if we need to take a 5 minutes, get up and dance, break, that's okay.
That's fine with me too. It would probably be okay. All right. Conceptually, so I think of Copperhead kind of like this. It's got, for provisioning I'm talking about, it's got some virtual tools and it's got some virtual storage arrays. And we were pretty big about making virtual things. And so virtual storage arrays are just shortened ideally to virtual array. And the idea of a virtual array is you could put physical resources in a virtual array, like physical storage arrays. Block or file. I'm going to talk pretty much all about block because block's what I do, and if you want to talk about file, we can try and go there. But, so, when I say a virtual array, it's going to have some physical resources, like some physical storage arrays. Might be native storage arrays, or they might be OpenStack storage arrays. Or after we redefine the architecture that we have an even better pluggable interface, not to say we have a good one right now, but if we had a really good one, then you could imagine, gobs and gobs of different kinds of storage arrays. Now, in a typical data center, our customer may have, I don't know, the ones that I typically see, maybe a dozen, but large data centers might have hundreds. So we have to think about scaling to hundreds. And then they use many different virtual arrays. Virtual pools conceptually are things that represent classes of service. So they're used in conjunction with a virtual array to say, I want my volumes to look like this, or I want my connectivity to look like that. So they give characteristics of the things that we're trying to provision that might narrow down our selection of the physical resources that are in the virtual array. So when you start with a bare virtual array, you can put any physical resources in it you want. Well, you can put, like you can mix array types, you can put them in there. So if you look in, where did I put that? Okay. So here I've got a really simple system. I was going to use the Copper HD simulator, and my simulator is inaccessible on the network today, so I had to use real hardware. So I've got two really simple pieces of hardware, a Vmax and a Vplex. And Copper HD does discovery, and we'll talk a little about how that discovery process works. That's one of the things I tried to walk you through. And basically, when you do physical discovery, you find out things about the arrays. Like for a Vmax, you find out the physical ports that are there, and you also find out the physical storage pools that are there. And I'm not going to walk you through, typing all the stuff in and discovering. It takes a minute or two, but it's not hard. So you do this, and then I've discovered a network system which we call a fabric manager. This happens to be a Brocade SAN switch, and the Brocade SAN switch will in turn let me see SAN fabrics, and these are displayed as networks. Now I can have different kinds of networks. I can have IP networks as well. SAN switches don't discover IP networks though, so this is going to give me all fiber channel networks. And you can see I've got a bunch. And I actually started, and I wanted to start just to get this going a little faster with a couple of virtual arrays. And so, first of all, Viper talks about physical assets as this tab. So you can see we've got storage systems and providers. Providers are essentially connection points that discover arrays. So they're not necessarily one-to-one. I might discover one provider and it might discover a lot of arrays. In this particular case, that didn't happen. Each provider gave me one. So you've got potentially data protection systems. These would be RP systems, recover point systems. Fabric managers we talked about as Brocade or Cisco switches. Networks are physical things that these things discover. We also have some support for UCS hardware and vBlocks that I'm not going to talk about, hosts and clusters and vCenters. And then we've got this controller tab down here that allows you to set controller-specific kinds of parameters that I won't talk about either. But in general, you've got these physical assets, and you go discover a few of them when you start up. And then you start provisioning virtual assets out of them. So a virtual array doesn't have to represent a site, but oftentimes I think it does. It represents, like I said, a collection of hardware resources, and maybe Sal wants to jump up in here and say what the real intent is. But I think of them as a locality or a group of resources that is somehow related. It's pretty arbitrary, really, what the user wants to do with a vPool.
What do you see normally in the customers? How do they group the resources? Is it by org or by function?
Could be by org or function or site. Oftentimes it's site if the sites aren't too big, like data center or
SAN island. The idea was the array and pool, like the virtual array was supposed to be where you want something. What kind of things do you want? The consumer had to be able to specify those two things. But the where was in this sort of abstract So if you had a data center with 7 sand islands, you might have 7 virtual arrays. You'd have to know enough to say which one is 7 of these. It also translates to IP networking in a similar.
I mean, in cases where you want to when you want to have like severe assurances that customers cannot access or touch in any way. It's an isolation point to customers. You can use it not just to aggregate multiple physical arrays, but you can even use it to split a physical array to virtual arrays, or 5, whatever.
So you can actually split an array and put it in separate virtual arrays, and some customers try and implement port groups by that. They try and take certain ports from the array and put them in this virtual array and certain ports from the array. That works to some degree. It has problems, and if you get a lot of virtual arrays, it gets kind of messy to manage. One place that we do this, speaking to vPlex, and this is my vPlex buddy Rob here, are that the 2 clusters of the vPlex we support Metro be in different virtual arrays. Those of you who don't know what a vPlex is, a vPlex, I think of it as a smart distributed cache coherence cache. Viper doesn't sit in the data path, but Viper can provision vPlex.
Olaf was like, he owes like $50. I'm sorry,
well,
$2 so far.
Viper's not in the data path, but vPlex is, and we provision vPlex. Copperhead. It starts to be $1 each time I say it, but $3.
Your method of is slow.
All right. Anyway, vPlex in a Metro configuration essentially has 2 caches, one for each site, but they're cache coherent between them. They're updated in about 10 milliseconds on that order, pretty quickly. And if you write in one cache, it goes to storage on both sides if the volume is configured as a distributed volume. So for that reason, to avoid confusion, we require that the 2 vPlex clusters be built. That's one specific requirement we have, but we have really very few requirements on you have to do this with a V array. Everything else, like one array and multiple V arrays, you can put part of an array in multiple V arrays, or
If customers who buy like a convert system, don't make that one V array. You know, that is the convert storage system, you use it in one V array.
Right. All right. Any questions about that? So that's kind of this. I'm starting on this next level picture here where I'm starting to talk about virtual arrays and virtual storage pools and the configuration of them. It's useful to talk about the different ways that you can set up the virtual array, though, so let me say a moment about that. You can put specific storage ports in a virtual array, specific physical storage pools in a virtual array, and specific networks. And if you don't put any storage ports or pools in a virtual array, then we will assume that if its ports and pools haven't been put in any virtual array, we will infer by connectivity that it should be in all the virtual arrays that have access to the networks that it's on. So there's some default settings where things just show up based on network, but you can override the settings with specifying individual storage ports or pools.
This is a great example where, like, we started out with this cloud mindset, where it's largely about aggregating. That's your use case, the cloud kind of use case is really simple. enterprise storage customers, there's all these weird things people like to do, and so for non-cloud, more traditional enterprise, all these weird things that people like to do. I want to reserve these 5 ports for this application, and reserve these. So there's all these stuff was added. So you have to look at it, what angle you. If you're coming in from a cloud, hey, just throw everything into one big aggregate and don't worry about it. If you're coming at it from all kinds of knobs you can tweak that we've added over 5 years of dealing with customers.
Map this into, let's say take Scale.io.
Well, so I'm not terribly familiar with Scale.io, but it's accessed via IP. So you do end up putting your Scale.io in a virtual array, either via the IP connectivity or just by.
Scale.io has
It's a converged infrastructure.
Traffic flows through ports. It's just the service.
Yeah, but you're not really managing them, right? As such,
Right.
it's not a management entity. Unlike fiber channel ports in an array.
You don't have to do multi-pass.
Yeah, exactly.
Right? It's much simpler.
Yeah.
Because it's any-to-any.
Yeah.
So like the whole SAN thing just goes away.
There is no, unless you're managing the physical ports on the Scale.io storage cluster, which is, if you have 100 machines, you are looking at, let's say, if it is a dual port, you mean those are the ports that will show up here?
They would, but you're just going to add the network. A situation like that, you're not going to do.
It's a special case. When you store Scale.io, Copperhead will generate, I think up to the VRA. I'll send an email and find out for sure. The network will be there, the host will get discovered, all the connectivity, because it's such a special case, like it'll just
Totally makes sense, but I think we're just trying to figure out the scale out storage stacks and how do we map into this semantic.
Right now we with more people.
Yeah.
But in the simple case, scale out by definition as well. Scale out system.
One virtual array,
Directly to
just map it and use
Now,
that.
Scale.io has some limits in the size of the protection domain, the size, how many spindles can go in a pool. So you're often, even if you have, one Scale.io system, you may end up with, if you have a larger environment, multiple protection domains, multiple pools, so there's still some aggregation. And scale-out storage eliminates some of the complexity that you had with. But there's still the need to categorize it and classify it and aggregate. There may be sanctions, but there may be, technological storage together. But access, most cases, logically work storage.
Yeah, I'm not suggesting we shouldn't manage them. I'm saying we need to have a cleaner way of story. Maybe storage ports do not make sense, so it won't even show up, things of that sort. It's it's not going to be one instance. You will see lots of those instances in a typical data center. You have to aggregate them and manage them. The concept of virtual array.
Let's go on. If you want, later in the week, I've got access to Scale.io. We can discover the Scale.io demo of that. Okay. Talked about virtual array. I'm not going to talk much about tenant and project other than to say tenants are users. Basically, the way I think of them, I don't think a lot about tenants and projects, to be honest. Projects, you can create multiple projects. We'll have to create one here in a second when we do provisioning, because you can't create a volume or anything really project. I'm going to talk about virtual pools next. I've talked about these brown or these gray physical things.
On the tenant, for those of you familiar with OpenStack, trying to think of what the tenant is. Pretty close to the V2 line.
So we discovered these things in the network. We're going to make some storage resources that are going to belong to a project, and we're going to eventually export them to a host if we want to do that. Might be block or file or whatever kind of resources. So
Your virtual array can be part of any number of pools, or only one pool?
I'll show you the association in a second.
Okay.
So virtual array is many-to-many with pool.
Many-to-many.
There's virtual pools and storage pools or physical storage pools. So, all right, I've got write-ups and descriptions of these that you can read. Let's make a quick virtual pool. So, since I have a Vmax and a Vplex, I think what I'll do is make a Vplex. For some reason, you absolutely have to have a description. Now, I can associate, remember I had two virtual arrays, I can associate this virtual pool so that it's usable with either of my virtual arrays. No problem there. I can specify the hardware if I want to. Virtual pools are really trying to give you the different attributes of the volumes and class of service you might want. So here I don't have any other protocols, so I have to choose fiber channel, but I could pick drive type. I could pick system type. I've only got one. Vplex doesn't provide storage, so it doesn't show up here. These are the hardware that's going to host the volumes. I can do thin provisioning.
So the drive type maps to your physical storage pool?
Yep. These parameters in the virtual pool affect the selection of what physical storage pools will be available when we do a provision. That's the way that it works. So the combination of the virtual array and the virtual pool provide the where and the how. And those affect the selection of both the physical array resources and the physical pools that we use. So now, we've got multipathing in here. I have mixed emotions looking back about whether this was the right place to put this or whether we would have been better to put it maybe in a separate structure of some kind, but for now that's in there. I'm not going to change it. I'm going to make this Vplex local because right now with only one array, I don't have another array, so I can't do a distributed volume. A distributed volume, remember, would go across both sides of the Vplex. This is a pretty simple deal. If I had recover point protection systems, or I could add like recover point protection systems here, or SRDF, or I could do, in the case of VPlex, I can specify things like a VPlex mirror by saying it needs a continuous copy. So I can do different things that affect the protection in data protection. I can grant access to certain tenants if I want. And in the automatic case, it's just going to match the characteristics I selected up there with the available physical storage pools that will satisfy those characteristics. So notice, for example, that I've selected thin provisioning. So notice that I get thin storage pools. Makes sense, right? So I'm going to save this. So now I need one other thing really to provision. I need a project. I've got a tenant. I'm effectively the root tenant, so I'm going to add a project. So now you go into the UI catalog service, and the catalog service is really cool. We do a lot of our testing just using catalogs. So I'll double click. So you've got basic block services, block protection. This would be like recover point protection and SRDF protection. You've got file provisioning. You've got then specific export services for different types of clients, like Linux or Windows or AIX or VMware, so forth. And then we have some migration services as well for migrating data from one volume to another. And this is intended to be extensible. It's not quite user extensible, but not too far away. It's certainly for someone in the Copper HD project, I think extending this catalog service is probably well within reach with a little training and experience. What?
Component migration. Like,
Is it
non-destructive, yeah.
Yes, we try and do non-destructive migration.
Infrastructure migration, or are you talking about the actual storage resource?
No, we're talking about storage resource migration.
Leveraging
So
these
that's
types of things, right?
Leveraging
storage
V-
resources. You
Yeah,
allow
leveraging
them to share.
VPlex, we would do non-destructive migration.
Right, for growth.
But it's an area that we want to expand. So let's go ahead and create a volume. So you might imagine that I have to specify a V-array, and I'll get choices of the ones that I have. As you might imagine, I've only got one virtual pool. I've got to get.
Why would I, when I want to create a volume, I just pick the virtual pool, let it go figure out where it wants to create. Why would I pick a VRA? Not make any sense. Because
Why would you create a volume somewhere that couldn't communicate with your host?
Yeah.
Okay. So where are you specifying that?
Host in your array better be able to see the same network.
Yeah.
To be mounted
Remember
in
that the V-array had the
represents
networks in it, and that's true
But
also
shouldn't that be
on
part
the
of
IP
the-
side.
Well, you could just have a long list of pools, but by choosing V-array, that limits you to the pools that are.
So when I create a block volume, I specify the VRA or the
It's right here.
Like,
so you have
the two questions you're
I have
answering
both
is
here.
where and what.
Yep, and you're answering both questions right on this screen.
Okay. So
This is where, and this is what, and this is who owns it. So you're really answering where, what, and who, and then you're also answering how much.
Host initiator.
That's your filter for the host site.
Exactly. The HBA better be in the same SAN network as one of the ports on the array, or you're never going to get a successful export.
And we're logging in here as a root, as super user, right? So Tom has the ability to see everything he's ever created. Like you get 10 virtual arrays to any virtual host, right? But through the permissions and the wonderfulness of you can actually say, well, user Earth can only see these 2 virtual arrays and can only use this 1 virtual group. So you as a administrator can limit what they have and then it gives them the choice, and this is what then allows you to do self-service later, and it's still safe.
So how do you map this to?
Virtual array are the endpoints for the host too, right?
Do you have the endpoint for the host?
They're in the networks, actually. The host technically doesn't belong to a virtual array. It belongs to a network or a set of networks. But networks belong to virtual arrays. So then from a given host, we can compute the connectivity to which virtual arrays that host can be seen in. So if I were instead to go to a different catalog item, block service for a host, you'll see down here I don't have any hosts defined, but it'll actually give me here storage type exclusive or shared means really am I exporting to a host or a cluster, and then the host or cluster name would show up here. And then I've still got the virtual array, virtual pool project.
So in that case, virtual array would be filtered to only ones.
I'm going to go to the trouble. I'll do a host for you later
So
if
the
you want.
exclusive meaning
Exclusive would be a single host.
it would be
Shared
a
would
single
be a cluster.
host. So where would you enter the host? Which field is
It's back under
so you basically go back to the
physical assets.
and then you
You can discover hosts, like you can add hosts for, say, Windows.
yeah, I have seen this one.
And
No,
you
in the
can
previous one when you say create a volume with exclusive.
Say exclusive, it will pull the list of hosts. If you say shared, it will pull the list of clusters. All right. Big diversion to show you some code, but I think a useful one.
What happens when you do the demo?
It gives you context.
All right. That's what we're after, right, is content.
Yeah.
All right. So I'm going to go back, and I'm going to click Order. And I hope this works. I haven't pre-tested it. It's brand new VM and database and whatever.
A live demo.
It's a live demo.
Demo of latest code. So
That's right.
Yes, it's master checked out today, so, hopefully it'll work.
anything goes.
Anything goes?
Remember Olaf's deal about asynchronous tasks? Well,
Yeah. So now I should have one here, and I do. And I got some stuff under it, and this stuff under it is a workflow. It actually comes from a workflow. I've got one task and a workflow. So now what we want to do is figure out how the heck, not in huge detail, but how the heck does the code support this? That's today's problem. So we've talked about virtual arrays. I've got an example here that shows you partitioning of an array across 2 virtual arrays and a vplex across 2 virtual arrays and sharing ports among virtual arrays. You can read all this. It tells you which ports are in which ones. And
So I think for the Hitachi, we should take this picture and show them how it will be for their. Into their.
Yeah, that's what we were talking about, the demo.
Yep.
So how you make the volume.
Otherwise, they don't connect normally. They think.
So this next section, block virtual pools, talks about what I showed you on the block virtual pool when we created one menu. And these are all the different items. I looked at the menu one day, and these are all the things I found, and I put them in the wiki. I don't know how useful that is. This tells you some of the advantages of using the virtual pools, but one nice thing about the way this is set up is the administrator goes off and creates the virtual arrays and virtual pools, right? In a self-provisioning or a storage of a service model, the end user doesn't need to know any of the details about any of this. So you can select from these 3 virtual pools and these 2 virtual arrays, go make those selections, type in the name and the size, and hit go. And he doesn't have to worry about all the details that the storage admin would need to worry about.
It's not even that, right? It's basically a specific catalog service. That's what. Content to your users.
Right.
I want to deploy MySQL database. It translates into 3 different.
In enterprises where this conversation is happening daily, where every request is a ticket and then the ticket gets asking what kind of storage do you need, are you going to use it every day, does it need to be really fast? You can just make all of those decisions as an admin ahead of time and then say, okay, the HR department, all of their applications are either this kind or that kind, and you can have that conversation ahead of time. So when the HR department needs more storage, they just go in and they say, I want this kind, 50 gigabytes, done. You know, and so instead of taking a week of having the same conversation over and over, every time you open a ticket, it becomes a 30-second thing, and the next 10 minutes you just go grab some coffee, come back, and it's done.
Hopefully the tenant admin has scoped that down so they don't have any choice but to pick the thing that you wanted them to use. Right.
Yeah.
Or just put the relevant choices. So it takes out the complexity of that overhead of extra communication that's the worst part. It's not that a ticket takes 10 weeks, it's that every ticket, 10 weeks. Every ticket takes 1 week, and out of that 1 week, the conversations happening are the same conversation over and over, unnecessarily.
So why did I pick this example, or an example like this? I think it shows off a couple of Copper HD's strengths. One is this abstraction. There's people that need to know the details of the storage provisioning, but you can provision storage without knowing those details. And the other one is, which I'm going to talk about a little more, is the vplex provisioning. We've just provisioned, or I don't know that we've finished. I better not say just provisioned. We're about to, I hope, unless we get an error on the vplex. Provision 3 different boxes in this one operation, because to do a vplex provisioning, and he's going to draw me a picture, you have to build the volume on the underlying array, here at Vmax. We have to export it from the Vmax to the vplex, and then we have to provision the vplex, and the vplex has a whole series of steps. You have to first just
Local or
global. This is global. This is the simplest vplex you can do. So you basically have to find the volume and what they call claim it, which means you're going to device, and then you make the device into a virtual device, and voila. So there's 4 different operations on the vplex. We created zones for the export. We both created and exported it on the Vmax, and this is all abstracted away from the user. This is why customers...
This is 30 minutes minimum as a guy who really knows what he's doing. Just sitting there, but you're going across software for the Vmax, software for the vplex, software for the host, doing each one in step.
And the switch is in there too. We didn't even cover.
Oh, yeah.
Cover switch.
This line is magic, but there's a switch here and a switch here, so you're doing zoning operations and so on and so forth. And you might be doing it, across both. That kind of setup.
Part of why I showed this is we'll talk a little about workflows. And a reasonable question would be, why the heck do I want a workflow, or do I need a workflow? And the reason is so we can build these more complex operations as we go. And Bill, is Bill around? I don't know where Bill went. Bill has worked a lot on RP, and I've worked a lot with his team, and he's and a bunch of people. We get into workflows that this is tiny. There's 20 to 30 steps configuring multiple VPlex volumes that serve as the source volume and the target volume and the journal volume for RPs across 2 or 3 different sites. And to me, it's what we do.
When you take arrays, aggregate them up into a virtual array, they each have pools in them, pool A and pool B, right? Storage pools then aggregate as well. You can aggregate those together, so if they're 10 gig and 10 gig, you get a 20 gig virtual pool?
Well, we don't really size virtual pools, and so the way that it works is this. If you go to provision a bunch of volumes, we can't split a volume across. But if you went to create 30 volumes in an order, which you can do, we can put 5 over there, and 5 over there, and 5 over there, or whatever. Right? So we don't ever split it a single volume, but multiple volumes can be split around.
Target of he picked a virtual pool as the target for this provisioning. Backend pools on 5 different arrays that could satisfy that same virtual pool label that different people that said I want.
That total presented to them?
I don't think virtual pools show a concept of space.
They just have it, or they maybe can satisfy the request or maybe not if the storage is too requested.
You can get the information, but it's not.
I can tell there's 11 pools, and I've created 2 resources, but
The main thing is the same underlying pool could be in multiple virtual pools, so there's
Right, so you don't really want to.
one-to-one.
So you can think of virtual pools as dynamic filters, where at the moment of usage, that's when it kicks in and figures out what I can use based on the parameters I'm using at the time. So that's why it's messy if you start putting numbers like that there.
Right.
You could at any time you could figure out what your potential space is.
Right.
Because you do have access. From here you can see which storage pools are available, and then there's another view where you can see how much space is available for each storage pool. But there isn't a single place where it shows you the whole thing.
So I think this is a good introduction. Let's go on down. So I talk here about file virtual pools. I'm not an expert in file. I did file in a past life in UIM. Evgeny has done some file work. You can ask him your file question. Evgeny knows a lot about many, many things. All right. So, going on down this wiki, I sort of did a high-level overview of provisioning, and then I went later and did a gory, detailed view of provisioning of the volume. But who can tell me, now's when the question comes, and I'll move it up so we don't have any cheaters here. How does this, so we created a volume, And I showed you at least it had a workflow. How does this go through the system? Somebody play it back to me and I'll help you on. Who wants to volunteer?
API service, authentication.
How did we get to the API service?
The REST API. No, it's in the load balancer.
Well,
It's
started
a
with
portal
the portal.
portal service.
That's all.
It's an API service, authentication, right? And then you have
The volume construct, I think, before that. I didn't know it.
Good, good.
In the database.
Yeah.
And then the volume concept created.
well, messing around with the database before you go to the controller service. That was the question I was asking. Why?
Good, good. This is good.
Lazy stuff.
The dummy entry, but
From API services directly to the database.
yeah, that's what's in it, right? This is the create volume workflow, right?
Yeah.
Yeah, the controller service, and then task ID and a set of associated with the task ID, dump it into the Cassandra database, and then you have a workflow attached to it, which is a bunch of steps. Create volume is one of them. You go and figure out what is the backend that you really need to go and create a volume and the driver, and then what is executing the workflow. It really depends on the virtual.
That's easy because I only have one node.
Oh, you got one node, all right.
Trick question.
But in theory, it could be any, and we'll walk through that in a bit. Okay, so that's a pretty good overview. I'm very impressed. You guys are paying attention and studying hard.
He gave me the question before, so I know the answer.
But it was on this page here.
So I have a question. You have one node. Presumably you're supposed to have a cluster, right? How does it work with one node? Did you modify it so that it in some way?
It doesn't care.
It doesn't care. It's a complex local volume.
Well, if something goes wrong, then
Right, so
one
node is how you say,
Yes, my Copperhead instance is not high availability, but I'm a developer. I don't care. I very rarely run HA. The only time I run HA is when I need to test scalability or like failover between nodes. I have done that, but you will drive yourself crazy pretty quick trying to follow this stuff.
Not easy to debug.
Now, I have some tools that help with that. For example, when we get logs in on a Jira, you know what a Jira is? Then we'll talk about Jira later. A bug report. When I get logs in, I get separate logs from each of the nodes. So I have like a tool that takes the logs and smushes them together in timestamp order so that I can look at them in the order of the system. The more nodes there are, and the more the problem might be across different services, the more complex it is to debug. Just saying. Start simple, start with the one node.
Not a developer will do more than one.
Yeah.
right. So it's actually Jira has separate logs every person, as you know, you can get.
Window in by time, you know about when your error happens.
Yeah.
So
You can do it.
Parameters for start time, end time, you can also specify those.
That's very good.
We have good facilities for that, but ultimately a zip file comes to me and it's splattered with logs and it's great fun. And it'll be great fun for you too, because one thing I think we're going to try and do before the end of the week here is let you guys look at a defect. All right, so provisioning.
It wasn't in the agenda.
All right. So, we had a request to provision. It came from the portal service. You were absolutely right. It went into the API service. And then we were kind of hazy. It makes a database entry. Yeah, because it's got to go from the API service. The API service really doesn't talk directly to the device. That's the first thing to know. So the API service needs to send it to the controller service, and that happens through what two services? Coordinator and DB, right? So basically, we have to make a representation of the volume that we want created in the database. Then we send essentially a message to the controller service that says, go get this representation and make this volume. Meantime, the API service creates a task because it needs to return immediately ID back up to the portal service, and the portal service displayed it on that little screen that I showed there. And the portal service also has access to the workflow steps. He can take that task and say, what workflow is associated with this, figure out what's underneath that task, and show the individual steps as they're completed.
So the task stuff, the coordinator service layer, or does it actually?
Complicated question.
Well, take a guess.
Well, it is in, it is in the database service, but there is some stuff that sits in the coordinator service. Yeah. What is it?
Well, not so much. When I think of a task, I think of this. Task. It's as good a time as any to jump into the database, right? So here's the task. Now, every data object, pretty much, that we have in our database extends data objects. I am in, the package for this is DB client source main blah 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 blah. And well, I guess what it ends with is important too. Model. Right? Things in this DB client that end in model, these are persistent objects.
And you do the development typically on Windows machine? Or how do you?
I do my development on Eclipse, but I almost never run. Got Eclipse on a Windows here, but
Eclipse on Windows, is that what you do normally?
Normally I run Eclipse on a Linux. Many other developers do.
We'll talk about different development patterns.
Yeah, I mean that's
later. It's up
everybody.
to your preference.
Everybody's got their own
There's mechanisms for doing it on Windows, on Linux, on Mac.
Now, the database is really cool. I have to hand it to Olaf or whoever invented this technology. But basically, if you want a persistent object, you tell it what column family. CF stands for column family. Other annotations, it might be class. And then you come down here, rather than annotating.
CF attributes, are they Cassandra attributes, or is it just your own shim layer?
I think it's our own shim layer. And then for each attribute, you can say, you know, it's got a name. It might be an index of some kind. So there's like, you know, there's like alternate ID indexes and named relation indexes, and I don't know. I've got a slide here later on that I'll talk about indexes and how to use them and that sort of thing. But basically, each field is annotated, and it has a getter and setter. They have to be public. Don't put any complicated stuff in here. Being it's a data model object, it just needs to be a fairly simple.
And it's got those annotations. It's got a, as Olaf said, you can accidentally modify the schema by creating a new one of these or changing one of these.
There's also a relation table, essentially, that shows for a resource, like a volume, what tasks are involved. In fact, let's look at volume. Right. The volume's a bit weird in that volume inherits from block object, and block object, we have different kinds of volumes, and so we use inheritance here. And this is as good a time to talk as any about the way inheritance works in the database. Inherit from the Java objects, but in the hierarchy, you can't run queries against the base class. You essentially, the base class here is block object, and let me show you a weird idiosyncrasy of our database.
Ultimately, yes, it will go down to data object.
You might ask, why am I telling you all this stupid stuff? Because I want you to know how to program the database, right? So, one that will get it regardless of whether it's a volume or like a block snapshot. I thought it was in here. Fetch. This is the base class, and this is how it handles inheritance. It looks at the type, and it does a switch and does different queries depending upon what type of object it really is that you're trying to fetch. So just be aware that inheritance support is not fully there in the database that we have, compared with something like Hibernate. I'm going to talk a lot more about the database. Don't worry. All right, so we got volume, and volume, sure enough, either in volume or in block object, we've got an association with task. What?
It's task. Get the shape.
Maybe I'm thinking of get task status. Why am I doing it this way? Fire out of me. So, all right. Maybe it doesn't work that way. Status where?
In data object.
Ah, I'm not far enough down.
Yeah.
Top status that I'm thinking of. So this will get you the basically an array of statuses for what have happened to any kind of volume or export. Relations like that, and I'll talk more about relations more formally in a bit. All right, so we don't make this volume, and this volume initially is created by whom? How would we go find that? Well, the answer is I gave you a table. I tried to make this easy for you. There's a list of the storage controller. So I talk about the provisioning request flows, and somewhere down here I gave you a table of all the different services. Here's all the different API services as of the time that I wrote this, what URL prefix they handle, and then a short description. And I happen to know that the one that we want is block service because I look at it a lot. So the obvious method name would be create volume, right? Create volume. So we came here. The comments in this are pretty good, so this is good. We're going to verify the user is authorized, just like Olaf said. He said that it happened really quick, and it did. We're going to get and validate the V-array. So we're looking at the parameters that were passed in. Those parameters that were on that order form come in the form of a REST body that's passed as part of the post request, right? So there's a parameter block, and the parameter block is called the volume create. You can find it here. When we talk about the forms that it can take, you can tell this is a post because it says so right here, right? And so this is how you tell what REST is.
So this is your REST API entry call.
Yeah, this is how you tell what it's responding to, right? So we're going to validate the V-array, we get the V-array, we're going to validate the virtual pool, and these are all big subroutines that check stuff. Then we're going to get this thing called a capabilities wrapper, which is an abstraction of the things that we didn't know at the time that we had the virtual array and the virtual pool. So things like the number of volumes and the size of the volumes, these end up in the capabilities wrapper. So we have some things that are only known at the time of the call, and then these get done. Then we go into something that we call placement. Placement is a deep subject if we want to go over it all. Capabilities block here. Good already. Not really do placement, maybe we do placement below. I drew a diagram of this though, so I won't and I'll describe it in some terms. Yeah. Alright, so let me back up. I've kind of digressed. I was at a high...
API service?
Yeah.
You said API?
Yeah, API service. Hold on, let me get there. So I've kind of digressed. We're in this API service. We're figuring out basically how to put a volume entry in the database so we can send it off to the controller so we can create it. So we're going to figure out the placement for it, which is what storage pool and array it's going to come.
And you put it in the database entry?
Yeah. Okay. Now, there's a problem with that in that on really complex configurations like RT configuration, placement can take sometimes 3 or 4 minutes, so it can take a really long time, and that's longer than we like, so we at least had some discussions about moving the placement. But early on when we did Viper, it wasn't a problem.
But right now it is in the API.
Things were simple. But the more and more complex the configurations get, the longer and longer placement does.
What makes it take so long?
So if you think about like RP-Vplex, it's got to figure out, a lot of this is pre-computed, but it's got to figure out the source volume, the target volume, the journal volumes for each of the sites. It's got to figure out the connectivity between the RP site and between the Vplex site, between the Vplex site and the arrays. So there's a lot of, it's got to figure out whether the arrays have storage, and basically it's kind of an NP-complete problem almost, in that you make some choices, and then that limits the choices you can make later on.
If I choose this storage pool, can I get matching pools on either side of it? Can I choose all these other things?
Right.
And then eventually the answer is no. Then you have to back all the way back to the beginning and pick a different starting point, basically.
Ideally, but we don't have the backtracking in, or very much backtracking in. So
it's all computation and database, but it's not talking to the devices, right?
no talking to the device. It's all, and the computation of who can talk to what is pre-computed, and there's a certain amount of that's all pre-computed except for the parts involving things like size. But I back up. So we're back here, we're making this a synchronous request, and I want to make you sure you understand the overall flow before I dive too much deeper. So this is the picture you need to get, because this ties it back to what Olaf presented. Basically, there's a block orchestration interface. In fact, this picture is the first picture I understood when I provisioned or tried to write anything for Viper. In day one, it was that picture that I wanted. So there's this block orchestration interface. It is the means by which the API service, is that the right one? Block orchestration controller, sorry, wrong one. Is the means by which the API service calls right. So he's got things like create volumes. What he takes is a list of volume descriptors, and in the volume descriptor is the URI of the database entry that describes the volume in more detail. So these are passed around in memory, basically in Zookeeper memory. So what happens is there's an RMI call made between the controller service and the API service to a version of an implementation of this interface.
Between the API service and the... Okay.
So if I look here, so if I look here, there's two implementations. There's the block controller impl, and this is simply stub functions that put the request on the dispatcher. So you'll see execute orchestrations called by all of them, and these are what we call the dispatcher. The dispatcher is the thing that is implemented in Zookeeper that pulls things in a queue. It's got several different queues. So when the API service makes an RMI call, it goes to this stub, and so for create volumes, all it does is it says execute orchestration, it says what the operation is, it passes the parameters, and execute orchestration goes through, puts it in Zookeeper on a queue. And that queue is available to any of the nodes, any of the Copper HD nodes, and they will pick items. They basically lock each thing they're going to pick and figure out if they got the lock with the counting semaphore. If they got it, then they process it. If they didn't get it, then they go get something else. So all the nodes are sitting there periodically trying to get work. All the controller service nodes trying to get work off this dispatcher queue. Once it gets into the dispatcher queue, they're going to go into the block to the other implementation of this.
So can you show the controller service?
Well, that's all in the dispatcher, and I don't think I want to get into the dispatcher.
So the dispatcher is part of...
It's part of the controller service.
Okay.
It's called dispatcher, so you can look at it. It's hard to follow, though.
It's a little complicated.
So that's why I don't want to get into it. You just need to know that it works for now. It won't be the first thing you'll change. I'll look hard at the first
No, just a callback. So how does
first pull request for changing the dispatcher.
Just a callback itself, right?
Well,
so
if you look at the top, you'll notice the
the
dispatcher is an implementation of distributed queue consumer, and so there's some infrastructure in the coordinator for implementation of distributed queue, and he is a consumer of those, and so he's got infrastructure that's sort of letting him pull things off that queue.
So which method actually gets called when we have...
Fix it on, and then the distributed queue consumer is a callback mechanism. I think basically he's got a thread going, and he pulls it out and calls the consumer, and the consumer invokes the actual routine. The important part to know about this as a user, as someone, let's say you want to implement a new call between the API service and the controller service, two things. One, it has to be serializable, and two, it can't be really huge because we're pretty protective of memory in the coordinator service. So by really huge, I mean if you've got arguments and stuff that are, say, more than 100 or 200K, that's pretty really huge. Have to watch out for that. And we actually have some checks in place to check that we don't get really huge requests and stuff like that. This is meant for passing a fairly small argument list around and then having big stuff in the database. So does everybody get kind of the whole overall flow? And then the controller service goes off, and we'll go a little deeper into that in a bit.
One other thing I'll throw in, since we talked about this before, in sort of the multi-node Viper/Copperhead, and using the Nginx and the last octet governing where it got routed, that all goes out the window as soon as it gets put into the distributed queue. At that point, it has no longer node affinity versus IP address. It's basically a bunch of competing services trying to get the lock and pull it off.
Even earlier, so the reason we have this RMI code internally don't need authentication anymore. But in essence, you are already, so you should think about API service and controller service really as one thing leading to two multiple processes. I mean, so there's kind of, it could be one process there anyways, between nodes and they call to someone else with different resources within the same process. Think about API service doing all this stuff that is non-local. And controller service is this thing that goes to the back and is
Said that perfectly, because I was going to add that if you didn't. The big thing in the controller service is getting that task back to the column. That's why when placement takes 4 minutes, it's a problem. And so I may talk later about locking as we get that deep. And one outcome of that is we don't really want any locking on the API side at all, because if you were to block on a lock, you're going to hold off that task, and the UI is going to appear to be dead, and then it'll be calling me and going, not a problem in the UI, it's down in the API server. So, yeah. So, each service has its own different sort of parameters. The controller service can take all the time it wants. The API service has got to get back pretty much right away.
So that's the key.
That's the expectation.
and your handling. Also has, does it have rollback and?
Well, we haven't even gotten workflows yet. No, we're still getting from the API service to the controller service. I'll get there. Don't worry. We've got all afternoon. I think. No, I guess Ben's got time. Ben will stop me when I've talked to him. All right. So now, the next thing I want to talk about, go into a little bit more detail. I talked about all the different services. You can look through here to find the favorite service you might want to fix or modify.
That was really nice, by the way.
Huh?
It's really convenient, that table.
Yeah. So I'm going to skip for now the part about discovery. If you want to come back and talk about discovery, I cover it in here. It's sort of similar. It uses different queues, and it's periodic based, so it works sort of similar, but not exactly the same. We can come back and talk about it. That is something we probably will want to talk about, maybe before or after you talk about changing the device interface. And big thing, I put a table here for you of the different classes involved for the various types of arrays that we support. So here you'll see the devices. We have this communication class that handles it, and we have a class that implements the interface that gets called, and then I talk about different capabilities, whether the array supports ports and pools, and whether it supports unmanaged resources. If it supports unmanaged resources, that means we can go discover existing things and then, like in existing volumes or exports on an array, and maybe ingest them into Viper.
Right, that's another big difference.
I also talk some about metering. I don't talk very much about it, but we do support metering, and by that I mean periodic collection of statistics from the arrays. We use them for two things, really. We make a special kind of Cassandra record called a time series, something or other, maybe just a time series, where we put statistics in periodically, usually every 30 minutes or hour, something like that. How much a port was used, or how much pool was used, or whatever. And so we support certain statistics. The other thing that we use it for that I'm not going to talk about other than this one sentence is we collect port busy statistics and CPU busy statistics from some of our arrays and use that to affect the port allocation algorithm. So metering is an important part of the product, but it didn't get much of a mention here, just a couple of paragraphs. No, because right now we don't have any automatic algorithms that choose among virtual arrays. The user's doing that over the phone. But it's something that you could consider. Closest thing we have is we sort of generate an aggregate number for a physical array, and we use that to bias a little bit our physical array selection in certain cases. All right, so starting down here at 234 provisioning, I did an early swath on provisioning that covered that flow through the dispatcher. And now I'm really going to talk about the nuts and bolts of provisioning down here, if you want to read it. So I wanted to show you kind of this diagram. So this is one reason why I think we've got a few challenges ahead of us to make our array interface more floodable. We have some of this has crept into the API service, and it comes in two classes. There's a scheduler, and scheduler is what's doing the placement. So that algorithm is dependent upon what kind of array it is in certain circumstances. So we've kind of got maybe a default scheduler. So let's see, we've got our basic storage scheduler, but we have a different one for recover point, and the recover point vplex scheduler is yet more complex. We have an SRDS scheduler and a vplex scheduler. Now, to be fair, recover point and vplex aren't simple arrays. These are protection systems or high availability systems. So you might not cover these, maybe at least initially, in your building of a public back-end array API, if you will. But it's something to think about. To me, and our ultimate goal should be to have these kinds of interfaces playable as well.
Right.
The other aspect of this is that there's some code in the API service that also gets called, and mostly it's doing validation types of things, or creation of the actual volume descriptors and volumes is done in this specific code per array. And these all inherit from block service API. It's an interface, and there's an abstract one. So mirrors are somewhat different, and you can see, again, RP and vplex and SRDS are all split out. So what that looks like,
Take out
it's pretty basic.
because those are multi-system, multi-site.
Yes.
Like for the basic case of
It's almost all the
we can
same.
attack that.
I would attack that first, but I would think ahead and let's think about making some of these algorithms pluggable, maybe. But yeah, the basic is basic, and yeah, they're all pretty much the same.
Because I think one of the things that makes writing a Cinder drive simple is that there's not a lot of
You kind of got this trade-off, right? Function and complexity.
But, okay, there's some level of basic functionality you can get without all this fancy stuff. How would you improve? Then, the really hairy stuff will probably be a much smaller set of people on the planet who will want to go right into those waters. And yeah, maybe Hitachi has some duplex like complicated multi-site thing. I'm sure they have those. I'm sure
they all want to do that. Yeah.
And so there'll need to be some people who do that, but that'll be like a much smaller kind of community.
I 100% agree. I just don't want to pull the wool over these people's eyes and say it's just all simple, because it's not. And when you get ready to discuss those problems, give Bill or I a call. And
so we can, if you want to develop, let's say for Hitachi, they have a webex-like solution. So you will have to write your own scheduler for Hitachi.
Today, I think that would be fair. I don't think that's where we ought to end up. I think rather we probably partitioned it by array type. We should probably partition it by pattern or some usage form.
Yeah, exactly. Right. That's what I was. We could, yeah, the usage.
That's what I'm thinking.
You reduce the delta, that kind of approach.
Pretty much most of the storage vendors have this. Some shape or form. So.
Let's move on. Let's see if we can find placement and then the call to the block service API impl pretty quick, and then I'll move over to the controller side. We fiddle a lot here with consistency groups. That probably ought to be pluggable too. That all arrays support consistency groups, but they get a lot of attention. You can see we've got a huge block of code right in the middle here that shouldn't be an inline block, really. Capabilities put. We're still working on a capabilities wrapper. Check in. Here is where we do placement, finally, way down here. So we've worried about consistency groups. We've just done, you saw me flipping through that. We're just now down to placement, right? This returns ultimately a list of recommendations, where a recommendation is put this volume on this physical storage pool of this array. That's what it does in basics, but it goes through, like I said, this code is subclass depending on array type. Then we're almost done, because once you've placed it, it comes down to create volumes, although that is with abstract API impl. But let's just go here. So this is the block service API create volumes. Default one is going to handle like the Vmax. There's a separate one for the Vplex. But most of these, I mean, in the default case, what this is really concerned with doing is making volume descriptors. And finally, down in here, I wanted to get down here because this is where we call the controller. Controller create volumes. It passes the volume descriptors in the task. We went through all that. We call the controller puts it on the dispatcher, and I'm going to pick it up on the other side. Should I go on, or do you want to take a little 5-minute break, or where are we at? Which sure was that.
5 minutes, I mean, it's been an hour, and yeah, it's kind of like the halfway point.
Yeah, I'm basically going to talk about the back end, and then I'm going to talk, meaning the controller service, then I'm going to talk about database and just a few other things I want you to be aware of. And
from the fire.
I'll be done 3:15, 3:30.
At this point, when we get down to this, we're largely going to unwind and return the task reference, and we're done with the synchronous call?
Yeah, in fact, that's the very next thing that happens, return task list, and it just unwinds all the way up and goes
So
out.
the synchronous call is done, the UI now has the task that it's starting to monitor, and then things are starting to go into the background at that point.
Right.
And that'll be where we pick up in our next episode.
So what you got to control
What will happen? Will provisioning fail? Will rollback fail? How many support calls will we get?
Is this useful?
Well, we're out of coffee. Okay, so.
Oh my gosh, the meeting's over.
Yes, it is.
Well, we're also out of
Or am I boring you?
Do I need to go get more coffee? How are we doing?
Very easy.
Yes? Okay, I'll go get more coffee.
That's tough to unwind.
Come.
Yes.
That's the, I'm
So it looks to me like
Coffee, man.
at least, you know, we're talking about like the abstraction layer. It looks like you guys have basically said these are the types of arrays that we have, like you said, not like so much by,
Right.
because you didn't need to worry about any others. You said, I got a V-flag, you know, I've got bang.
Well, yeah, we started out incrementally, and further, we were siloed.
Yeah.
We have a VPlex team, we have an RP team, we have a
Give it
VMAX team, and so by being siloed and by starting at VMAX, and then, oh, we have to add VPlex, well, we'll make a subclass for that. Oh, we have to add RP, oh, we'll make a subclass for that. Oh, RP VPlex, ooh, that needs a subclass for the combination. And we sort of evolved there, and it's time to rethink that.
I agree. Yeah, because when I looked at that, I was sitting there thinking, yeah, but one of these are, I see synchronous replication pattern, you know, there's a couple of these guys that fit into a broader pattern, because this would reduce the gap to the individual, I guess, the diff. It would shrink the diff down a bit, and some of them have to write.
Right.
Yeah. I get why it's that way. It makes sense.
We were the first thing, morning of the first day, everybody was like,
Yeah, but there's the kind of improvement that's tough when you have a product that's supposed to run shit.
Overtime, but you have a flag.
Yeah, oh, I agree, yeah. I get a sticker. For other people.
Or,
Sure. I have to worry about a lot less. There's less interesting than I get power too. I feel like right now, I have to write my own. The more I have to write, the more opportunity I have to
You can't. You get a pretty primitive view, but you can't.
Write in this model,
Yeah.
and it won't take more than a month for
Yeah.
We're not getting them through the D-Plex right now, but we get them
if the array has a
for VMAX.
and for a model, we don't really.
There's CPU percent busy for this one, the number of volumes, we think the volume over there.
That's busy, like, what is it, some average?
That's the director's CPU.
Yeah,
These are averaged over time.
Yeah, I
So this one's busier.
Okay, so this is just the one number, but,
Oh, time series you can't look at, but you can retrieve. There's an API call for that.
REST.
REST API. You'll send me an email, I'll dig it up. I don't deal much with the time series, I deal more with the group. If you want access to the time series, either figure it out or we might be able to figure it out because probably in that table would be made.
One thing I'm curious about, I don't know if you know this, I'm curious.
Probably got its own service.
Well, about it earlier about, yeah, that log, you can export it in like this log, right? You can export it in maybe some standard format for some kind of external system to...
It would be called the metering service. Take a look at the metering service. It's called metering. Copper HD.
Full mechanism definitely.
Second question. Physical storage and physical pools. For example, right now in VMAX, in the latest VMAX array, there's a concept of storage pool where several pools are combined together and you can allocate volume of this SSD on this pool. Oh, there is? Like,
I got all excited for a second.
Path to control on where exactly your volume is located, on which pool, how many capacity of which pool is used, and so on. It will move the data between
Yes, we
pools
support
and
that. I don't know about the SRS, but if you'll send mail to Amir Jabbar.
Oh, right. Oh, this
Live migration sounds like.
What Amir's email looks like, you mean?
No, I mean, if you already support path,
Yeah, sure. If I go select. Or settings for VMAX 3. So there will be, I think there will be a separate VMAX 3 setting. I think it would show up as an auto turing policy report. And Amir could tell you how those are mapped to, as I understand it, VMAX 3 has like a fixed set of turing policies, like 16 or something like that. Those are all available through the. They also support bandwidth limit. Bandwidth limit.
okay. Somewhere, I don't
Back here you
know
can
where.
see the first one. These only show up if you select VMAX. If you don't select VMAX, they go.
I will not see this one.
Yeah, they go away.
I will write it down from someone in email or the person you mentioned.
If you've got a pen, I'll see how to write where I got it over here, but.
I can't go ahead and launch that in my VM. Well, that was one of the use cases. But the bigger use case was around configuration of the got half a day to that. So that's why it's required for remote.
It's very easy to put them. You need a skill on the client.
When you develop.
No, I don't.
Oh, you don't have analytics. Yours is just for demo.
Yep.
Oh, yeah, that's
The reason is if you develop on Windows, you have to copy the files from there to DevKit or to whatever your installation is. I don't like doing that. So.
Uh-oh. I added to your, I know that you're the Bay Grant.
Those aren't authorized. Yeah, because I just started playing with the code, and so I downloaded all the code on my Mac.
Run another one.
Clips, then I export a share to a Linux VM, so I can build on that, but I don't know if that's the best way to do it. People build on Mac.
Oh, yeah.
Different ways.
The other one that needs to go up there.
Pretty much it keeps it very slow if you have a VM.
Oh, I run it in a VM all the time.
You do? What's how much?
60
That's fine.
Yeah, I use a lot of memory.
So your VM is on a server then, not on your...
And in fact, for Copper HD, I made build when the server was just for home.
They need,
want to be
they need
effective.
better laptop.
That's what you need.
Or a server with 16 gig VM. Either one of them.
They can have the ladder of those.
Josh is not giving them.
I find the laptop pretty confining. I have a 25-inch monitor and another monitor right
EMC donate.
The other thing that I thought that I've heard so far I wanted to put up on the parking board was the abstraction construct for the scale out. That to me is that feels not.
Do you like virtual array?
Huh?
I don't.
No,
confusing.
No, it doesn't. Well, it might make sense for like a specific type of thing.
But virtual array is confusing if you want to use scale IO.
Well, to me, it's not just good. It's scale out first and stuff. You know,
I can't say 50 years. I'm just saying scale IO. I'm barred from saying that.
All right.
EMC port.
I think I'm going to get started. I've lost a few people.
What happens when you go through the code?
You lose everybody.
It depends whether you want attention or
to get coffee.
Well,
But there's anyone waiting to get back in?
no, they went for a special coffee. We are not getting anything.
that's all right. But I mean,
Just keep going.
the goal of this meeting is so you guys can write code.
Yeah,
The goal.
Yeah,
you have the captive audience. Go ahead.
I can write code, but I'll break
No, I mean write code. Write code that will fit with this.
Right, good code.
No,
You cannot break
I'm not saying good or bad. I'm just saying that we'll.
So we can all write code. It doesn't matter whether it works or not.
Oh, yes, it does. All right.
Comments are considered code too.
All right. So I talked about we would call
Completed API service so far.
yeah,
Dropped into a queue on the controller service.
I'm looking for this one. And back to the interface of this. Go back here. So this naming convention holds pretty well across everything. You'll see the block, or you'll see the XXX controller, and that's an interface into the controller. And then you'll see the XXX controller impl, and that's the thing that puts it on the queues, and then you'll see the XXX device controller, and that's the thing that does it. And that naming convention is followed pretty well. So, all right.
So she has documented, Shujin has documented the
I saw it was about 6 pages, and I didn't understand the first page real well, but it
we have the same feeling about your wiki page too. I'm just kidding. I'm just kidding.
All right. So now I'm going to introduce you to workflows, and I'll start with why do we need a workflow for the example that I showed you? Yeah, the create volume example that the provisioning I showed you.
The question is, why do we need it?
Why do we need it?
Operations, right? Discrete operations that you want to go and run.
That are tied together, right? The success or
Each
failure.
one is probably one driver method call, hopefully, or a database call, whatever it is.
Yeah. So they basically turn around and get dispatched back through the dispatcher, each individual workflow step. So this method that gets called when you do create volume, his job is to build the workflow. So what you see him do is he gets the volume descriptors. This is the list of volumes that he wants to create. It might be more than one.
Is it a UUID? What exactly is the volume descriptor?
Volume descriptor is an aggregate structure that contains the UUID, but it also tells you what kind of volume it is. So like for the example we had, we're going to have one of these marked as a block volume. And so the low-level block volume controller knows I'm supposed to do this one.
Okay.
But he won't, when he sees the vplex virtual volume, he'll say, oh, that one's not for me, and he'll ignore it. So this is kind of the switchboard that tells him which things to look at. So the volume descriptor is just a way of organizing the arguments, and there's routines in here that will filter, like, give me all the volume descriptors of a given type, or whatever, or for a given device, or so forth. Split them out by device. It's just a convenient shorthand way of passing an arbitrary number of volumes, right? So for this particular request, like I said, we would have a volume descriptor for the array volume and a separate volume descriptor for the virtual volume. And so different pieces of code will process each one, constructing a workflow where the vplex volume depends on the array volume. So there will be the dependency. And so what you see is we're going to start with the block device control.
Sequence is enforced with the workflow.
Yeah. But further, we're going to start building the workflow from the bottom up. We're going to start with the block controller, the Vmax in this case. We'll say, okay, we need a Vmax call. And so what he's going to do is he's going to build a workflow step that will execute it, build that volume.
So this is basically equivalent to all the
schedulers are doing placement. So on the API side, scheduler means schedule this virtual pool to this physical storage. So it's not so much doing the steps.
logically you have those discrete operations from the API service. Some of those may translate into the actual controller service classes that may have to implement.
So as far as we get, we don't know about the steps on the API side, but what we do is we build descriptors for each of the volumes that we need. then the first thing we do on the controller side is take the descriptors and convert them into steps.
Here you are like webex, for example.
Webex steps. So what we're going to do is we're going to go into the block device controller, and he's going to look for steps that he needs to create. So just looking inside here, these are the kinds of volumes that he knows how to create. So he's going to filter the volume descriptors by that, and then he's going to come down here and he's going to map them according to pool and whether they need meta volumes and yada yada yada. But basically he's going to get down to workflow create steps for as many steps as he needs to do to create all those volumes. Might be one step, but if he's got a bunch of volumes, it might be a bunch of different steps. The volumes might be on different arrays, they might be in different pools. He figures all that out and inserts a bunch of steps. He gets passed in a wait for argument. And the wait for is how you create dependence when the workflow executes. So initially the wait for is going to be null, which says don't wait on anything, just execute. He can chain his steps together in a serial fashion, or he can just wait for it, or he can do them in parallel. There's the notion of a step group that I probably won't talk about much, where you can group different steps into a group, and rather than waiting on a step, you can wait on a step group. So you can do that. So at the end, he returns back his wait for, which is the last step that he wants executed before the next thing starts off. So by doing this, and then we're going to call the next level in the workflow, he's going to call SRDF. Well, we didn't have any SRDF in that example. Then he's going to call VPlex. And VPlex is going to
do... If I want to do this for NetApp or Hitachi, I'll have to add this in the code. Ideally, not.
Yeah.
We need to figure out a way to construct these through plugins. We need a way to order them, though, because if we support a Hitachi and we want to support it behind VPlex, the Hitachi needs to run before the VPlex, so that the VPlex knows the details of volume that's being created.
Does VPlex manage the Hitachi system? Or
actually, we support Hitachi behind the HDS.
Functional reason that you couldn't like ingest these out of like configuration, so versus code.
No, not this part. We didn't make the workflows that way because we had workflows in UIM. Ben will remember UIM. Found was that almost invariably when you change the XML, also ended up having to change the code anyway. So it didn't seem to be worth the trouble. But if you develop a plug-in system, you need a way to control the ordering, and then you need a way... The arguments here are pretty cut and dry. Everybody gets their volume descriptors, so that's pretty easy. But you can do something that might turn this into a plug-in.
How often does that stuff change? How often does workflow stuff change for you guys? So not just the new stuff, because that's what you're talking about. You're talking about new. But let's just talk about like, just ongoing. Like, how often do you guys change that stuff? The pain is that you spend a little bit more time up front, but I think that's your argument with this UIM, right? You're saying...
Yeah, I mean, I think UIM's workflow system, it tried to be, it was sort of a third-party workflow engine at the heart of it, and so there were some XML-based configurations. Really effectively make very many changes to just by taking.
Not all you could do was skip a step.
Yeah.
That was effectively all you were ever able to do. So it didn't seem useful. One reason we have our own workflow system, which I'm sure you So the steps get executed by queuing onto the step. Step finishes, the control of the workflow is actually distributed across all the nodes. So when a step finishes, he grabs a lock that protects that workflow, updates the state of the workflow, potentially fires off other steps that may execute on different nodes. So it's all distributed. That was the primary driver for having a separate. All right, so this then, the Vplex guy is going to go, he's going to go execute and load the workflow. It's probably instructive to say, how do I find what gets executed? So remember I showed you create step a minute ago. So the documentation's pretty good here. It tells you what all the parameters are for. But basically there's two methods here, an execute method and a rollback method. The execute method gets called in forward dependence order based according to the wait fors that I was describing. Something. So we'll go through and we'll start with the one that didn't have a wait for, and we'll execute it, and if it succeeds, we'll execute it. We get to the end, and there are no more steps. End of that, we have our Vplex virtual volume. So going back to our example, what we had there was create a volume. We had an export step that did zoning and exporting on the Vmax, and then creating the virtual volume. So basically 3 steps. At the end of that, you might ask, well, how did all that get back to the UI? At the end of that, the workflow service knows how to fire a task completer. And a task completer is something that is used all over the place. So you'll see it here with as a volume create workflow completer. But basically, these all inherit. Talking so long.
Max, Tom, maybe some sugar high.
Forgotten how to run a clip. Here we go. So there's just millions of completers. But completers are the standard way that when a task completes, it gets sent back to the UI. And basically, they update the database record, maybe both for the object that's affected, like the volume or the block object, as well as for the task. So they'll usually update 2 database records. Well, these update the database records. The UI is essentially pulling.
UI is from the database, right?
Pulling the REST API, which is reflecting the database.
But it's pulling from the database.
I have the REST APIs. The UI is a REST client. It's not a database client.
The UI asks API service.
API service is directly back to the database. That's what I mean,
Yeah. But what they said
yeah. Whatever they say.
more accurate.
Okay.
But it amounts to the same thing. We change the database records, they're pulling through the REST API,
Good.
and each task has an operation status. There were 3 states until, I don't know if that check-in's happened yet. Pending, which means we're working on it. Error, which means it failed, and okay, which means it succeeded. And now with Ian Bibby is checked in, there's queued. And clocked waiting on some semaphore on distributed own lock, basically.
Decaffeinated by now.
All right. Any questions on this? Otherwise, I'm going to drive into the execution because I want to show you all the way down sort of into the Vmax code and the Vplex code, just so you get a feel how we
can go through the driver code.
All right. So we've been through. Oh, if you want more details on workflow, there aren't very many pages in the wiki yet. Let me back up. There's thousands of pages in the internal wiki that we have not had time to proofread, convert, or update to get to the external wiki. So you guys lobby for them, but what would be more useful than lobbying?
We have the lobbyists right here.
What would be more useful than lobbying is tell us which
charge.
ones would be most helpful. What do you need information on first so we can prioritize?
Where the gaps are that are plaguing you, and we'll fill them before we
exactly.
waste time on stuff that's not.
Because there literally are thousands of pages of internal wiki. Well,
That will be detrimental.
yeah.
So developers trying to do some work because
Well, we want to post what you need. But anyway, under this page, there's a child page. I thought, did it not get moved here?
okay, so I'm kind of a little bit lost track on this. So the workflow step actually gets the workflow step that actually created with the sequence in a certain sequence, whether it is sequentially or parallel with dependency, whatever it is. So you have series of things that need to be done.
They don't
And
have to
are
be.
they going into the database? Where are they?
They're going into Zookeeper.
Zookeeper in memory. Okay.
They also get archived to the database.
They do. Okay.
Yeah.
And okay.
The order of creation is not the same as the order of execution. You can create the steps in any order, but execute them in a different order.
Now you are confusing me because the execution of a workflow based on how it is defined, it can be parallel, it can be sequential. So if it is sequential, you are following the sequential, right? No?
All I'm saying is, as you create it, you specify what a step waits on.
Right.
So I could specify, I'm going to create C that waits on B first,
Okay.
and then create D.
Right.
Although that would be a little hard to do, but you don't have to create them in the same order that they're going to execute. Take the step, you tell it the dependencies,
Right.
and those are what's used when we
When you execute, yeah, okay, that's what it is, okay.
That's what I'm trying to do.
Okay.
The details of that are in this workflow service page. You do have that.
Okay, okay.
And, I put it in the same time I put the other one. So this will tell you enough to be dangerous with workflow.
And then when it rolls, it has to roll
Two
back.
other things I want to say about workflows that are pretty important. One is we almost always need a rollback step because the default action when something fails is the workflow will try to roll itself back. Undo what it was doing. If a workflow has executed a step that doesn't have a rollback step, that won't be possible. So it will throw an error and leave the system in what almost never what the user wants. The user wants it cleaned up out of the terminal state rather than, say, a Vplex volume has created. So rollback steps are important. There's many, many examples of writing them. They operate in the reverse dependence because they were modeled after the volume create. There are some situations in which that's not ideal, like say export. Always want to roll back in reverse order.
So we didn't specify the rollback. We didn't. So you just talked about the workflow steps.
Yeah.
Was there a rollback?
Yeah. You were looking close enough.
Okay, that looks like it.
Well,
The caffeine problem.
yeah. It's, I mentioned it when I was staring at code like this, but I did it really quickly. There's an argument here for a create, and here's an argument for a rollback. And these are both method types, and these methods are what's executed. The first one's on the when you're actually executing, and the second one's the rollback. Okay. But I'm trying to hurry. There's a lot. The other really important thing to know about workflow steps is they need to be item potent. There are a number of reasons for this, but one reason is, are you guys listening, or if I put everyone to sleep? Why do they need to be item potent?
Are you asking them?
Yeah.
Hey,
it ought to be
there
item
is a question coming from Tom.
Why does a workflow step need to be item potent?
Why?
Why?
Does a what?
Does a workflow step need to be item potent?
Oh crap. Okay. The other thing is okay.
I wasn't asking you in particular. Yes, it does.
The overall system would be different after
Here's the answer. Think back to Olaf's presentation. Node dies. A Viper node dies in the middle of a workflow step. What's going to happen?
Somebody else needs to pick it up.
I haven't told you, but yeah, somebody else needs to pick it up.
Execute from there.
So what happens in that case? We re-execute the same step, thereby we need the steps to be item potent.
From a workflow step or the rollback step?
Both.
Both.
Either one, we could die during either one, right?
Yeah.
Something to know.
And
that's a, huh?
That's a transactional?
Sorry?
I would call that transaction.
No. Item potent means you can execute it twice and not have an ill effect, right?
No, that's why. So creating one volume, if I create the same volume again, create another volume. So that's not either potent.
Well, I think the right word for that is item potent.
Yeah, okay, fine.
Transactional means it either all completes or doesn't.
Yeah. Can you go to the architecture page?
Yeah.
Just want to see that it behaves the same for you. No, up to the top.
He's debugging a web page about the very
The very top architecture page. Yeah, one more higher.
He's trying to rush it. You're trying to make
and then go to workflow service.
Oh yeah, that should work.
Why don't these guys? Why can't these guys see it? They get taken to Jira.
When I click on the...
Oh, look at the restrictions. There must be some.
He must be logged in already.
I don't know how to deal with.
That's fine. We'll figure it out right
I
away.
don't know how to do restrictions. You guys.
Yeah.
I'll take a look.
Yep. I don't know what that's going on, but
Hang on. It's not item potent.
Ben would become an expert.
All right.
Hey, it's a hackathon. We fix things on the fly,
There you go. All right. So now we're going to create our Vmax volume. So we come into, I believe that's a block device controller. And I just want to show you how we get into the So earlier, you recall, when we were building the workflow, we called add steps for create volumes here. Now we're going to, in the same class, call create volume, or create volume. Now we're in here, and we're actually doing it, and we're going to try and create a Vmax volume. And so we're going to go find stuff out of the database. So here's us finding the vpool out of the database. we're going to say that our step is executing. That's a really nice thing to do because that's what updates the display in the UI. At the end, you'll say somehow the step has to get completed. Normally that happens in the completer, or there's a variety of ways that can happen. But if you throw an exception, you might need to do something about that. So you'll see a catch exception, workflow step completer, step fails. So that's important to do. Yeah. But basically you're going to do this get storage system, get system type, do create volume. And that's going to take you a level down to the block storage device. And block storage device, I describe all this in the wiki, by the way. There's a default implementation. One that we want for the here's different implementations of block storage device. These are the things that begin to really talk to the array. So we've got SMIS storage device, and it's got to call do create volume. And so this is going to come down, and it's going to try and start to talk SMIS language pretty soon.
Yeah, Tom, just can you show the scale I want?
Sure.
Yeah, later on.
All right, so yeah, here's scale IO volume. Here's a handle. Scale IO handle is probably a communication interface to scale IO.
Okay.
And we're calling some routine. There's probably a scale IO library.
Okay, can you show me how it is actually coming to the scale IO volume? Or just the glue piece is the one that I could not.
You couldn't figure out how you got here?
Yeah, so you have a driver.
Yeah, I'll go back.
Driver resistance.
Through that.
Based on the storage device type.
So you have the
I
storage
had that
device
on
type.
the screen a second ago.
And you have a switch that is actually calling each one of them based on the type.
Configuration file.
It's going through the config file.
Right here, get device, get system type.
Okay, where is the config file? What is the name?
SolarService.com, right?
Okay, so I think one thing that we didn't look at, but did you guys look what is under storage.com? So, we're using, effectively, Java framework. It's a wider thing, but it's also used to configure what the actual values for this mapping.
Yeah, so this thing here, this devices, is a map of device type to the spring controller that implements it, right?
I see, okay.
So that's how you get there. You make this call, get device, storage system, get type, and then you call. So it's easy to miss, right? Because it's not at all clear how you.
And this is a pattern using a number of places where you have some code that actually doesn't have, a switch statement in the code.
It's coming from the
But it's called
framework.
map get, right? And so the map is actually the actual literal source. I don't like it, but that's the way we use it.
I never formed an opinion about it. It was here long before I got here. So
we won't form any opinion either. We are way behind you guys. So.
All right. So anyway, I'm going to go back. I'm going to go back to the
The
VMAX.
new joinees of the project forming an opinion is a good thing. Then we can get new ideas.
Opinions are
No,
fine.
not these small things.
No, opinions are fine. I don't mind them. I'm just saying. I just went with the flow.
So I mean, this is not something that we're the only first people using this. I mean, at the same time, this cassette, and nobody knows. So the boot is right now slow, and like
Bootstrap is low.
I mean, so we look how long it takes for nodes to come up and for all services to come up, but it's not clear whether you are the fetcher,
just reading that,
instructors and so on, or whether you're spending time in framework trying to figure everything. Extra research is something.
I'm almost done, guys. So we're down here. We're in SMIS storage device, and we're starting to talk SIM. We've got SIM object path, and our providers for the VMAX and the VNX talk SIM. I'll show you the vplex one in just a second, how the vplex create volume works, but it's different. It's not subclass off this. So there are different models about how to do this, but this is going to talk SIM, and it's going to get, it's got this thing called a helper, which does a lot of the argument formatting. The SMIS command helper is a good class to know about if you care about the SIM-based arrays. This formats all the arguments and the calls, and these two classes work together. You can see these are huge too. There's lots of different. But we've gone all the way from the API service all the way down to making a SIM call. That was what I wanted to show you. The one other thing I'll show you is the vplex is a little bit different. So the vplex has a device controller. Remember I told you that device controller was a fairly common pattern. It's got a create volumes entry point. So this time of day I can't tell if I need my glasses or don't. Quarter thingy is always in the way. I think this is the step. So I think the arguments get formatted for the step here, and here the vplex has a dedicated client to it, and so there's a library, there's a directory. I often wondered for a while, it's export libraries, and I never quite understood why it was called export libraries, I think is the name, but it's libraries vplex. And then this has libraries of different stuff to talk to different arrays. There's a vplex library.
KLIO clients too, they are in the export library.
So let's just look where we make the vplex call real quickly. It's going to be right down here. This is in the vplex API client, which is in that export library, and a whole library that just deals with vplex. So that's another way that we interface to devices. So some devices have a library, some devices use SMIS or some common format, some stuff is shared between the different libraries, and some stuff is not. So the pattern isn't exactly the same for all different devices down here. You'll see some differences. I I think of it,
we have a thing.
it's the lowest level interface. It's the thing that actually does the talking to the device. If that's what you mean by driver, yeah, it's the driver. But that doesn't mean to say it has all the VFlex dependencies, because I've shown you other places.
Right, exactly.
There are two places.
The answer is we don't have a concept of a driver that's one piece of code in Copperhead as it stands now. We have sort of the communication channel.
And I think Evgeny is well versed to lead a conversation on this tomorrow.
Yeah.
But I wanted no holds barred to show you what we have. I'm not trying to pull the wool over your eyes and say everything's great. You just plug in 3 things and
Software is never great.
But what we have works pretty well, and we've got, what, 100 man-years in this project, probably? Probably easily, hundreds of man-years.
500 people. There's got to be 500 man-years, or it's been like 3-4 years, right?
Right. Hundreds of man-years. So, I have taken you on a survey. I hope it was useful. If you want to go in more detail about something, I'll be here the other 2 days. I'll be happy to break out in a breakout session with you guys or whatever. Welcome to send me an email. People will tell you though I'm pretty busy. I will try.
You don't respond.
Huh?
No, he'll get back to you. It's just not going to be instant.
I will try. And Uro can bug me if I don't. I think this effort is very important, but I have 23 pull requests in my review too, just to give you an idea.
I get to start reviewing.
Yep.
So I appreciate it. And any quick questions? Otherwise, I'm going to let Ben get started.
Good. Thanks for the breakdown. Very helpful.
All right. So I think copy that was acquired, courtesy of our support staff.
Right.
We have.
Before we move on, though, I have a few announcements. Well, one big announcement. And I got a bit of an answer for this. Remember, we were talking about when you discover Scale.io, what happens? Does it create? Do you put software, networks, etc.? So when you discover Scale.io, Copperhead will automatically create the network and the host. And if you have already discovered the host, then it will match them up to the hosts that are connected to Copperhead. Sorry, to Scale.io.
How can you create the network?
How can it discover the network? Because
you said create or discover?
Create and discover both.
Well, when he says
you end up with a Scale.io network.
When he says create the network, he means the Viper, the
Copperhead.
Other dog.
$5.
Yeah, the Copperhead database entry for a network which physically existed that we discovered through the Scale.io appliance.
Right. So he'll discover the one over there, and it will create it in Copperhead.
So he just pulls the Scale.io cluster network and tags that.
Puts it in and creates the host and all the information and all of that, so it knows that, okay, this thing can see these hosts and vice versa. So that when later on you want to create you want to create devices that go on a host, then it knows where you're going. The big announcement.
This is one of these double-edged sword things. It's really easy to find a host in Scale.io because you have to install a Scale.io bit of software on every host that's going to access volume. That's a pain, but once you've done that, you can figure out where all the hosts that are out there that can possibly talk to the
Correct.
A little bit of a double-edged sword.
So is that what this was about, or is there something else we need to talk here?
No, I think this is probably a bigger discussion. So.
A bigger discussion, so we'll leave it there. Okay.
But it's probably not going to be for.
The second thing I wanted to announce is that support for the free Scale.io version is now online. I just got the email that the code is in the master branch. So we should be able to discover the brand new Scale.io that wasn't working a month ago. That stuff should work now.
You mean the Scale.io portion of the driver?
Yeah.
Scale.io driver. But the Scale.io changes to work for that bug.
Yeah, like we can now discover the free scale I/O.
But not the scale I/O software itself, it's separate.
I have no idea what you're saying.
Well, the bug was... We went off track, we thought you were talking about posting the scale I/O source code on now work.
No, which one? Why would you think that?
Did they do a new rev of scale I/O?
You're twisting my words, Red.
Updated Copperhead?
The Copperhead driver.
Okay. I didn't know if I had to
No,
reinstall scale I/O.
but wait a minute, okay, so it's great, the code is in the ground, it's the main truck, but there's a million other changes in the main. Like, at what point do we get a stable?
Supposedly today we can discover and start using it.
I know, but that means somebody takes the main branch and
Just it.
maybe there's a million other changes that went in and it's not quite like.
It's merged, right?
Amir told me, I asked him, when can I start using it? And he's like, now. Like, really? Now? Like, I can discover it and use it? He's like, yeah. Okay.
Right, so somebody could check out.
Yes, we can check it out, build it,
and whatnot.
and then point it to a brand new, one of the new Scale I/O ones that is free, and it should just work. Now, I'm sure it's going to be buggy, and we'll fix it. We'll figure it out, but you guys, we can all test it now.
So there are all the places people can go to get pre-compiled versions of stuff, pre-built versions.
We don't have any of those.
Those don't get updated every time there's a new build up.
Well, we don't really have it, there's nowhere that we say, hey, go download a built Copperhead, that's kind of, you go build it yourself. Technically, you can go to the Jenkins server that does our integration builds and grab an RPM, but, and yes, that gets, every check-in, we build another one of those. But we're not really advertising download a binary of Copperhead. That's kind of not what we're...
Yes, there is a pre-built if you know that we have a continuous integration thing and you go grab it from there. Because it's open, but I don't wanna be on the hook to say at least we as a Copperhead community have not decided at this time to release a build thing. That's part of why we're gonna have this discussion to see if we start doing that. Yeah.
And his argument was to make it
it's two different things here.
one is building it,
host.
and the second is what kind of packaging for deployment. Those are two separate.
I'll do it on my...
It'd be good to have a built version, so I don't have to compile and see, whatever.
Yeah.
But we don't want to go overboard with all these fancy packages.
Well, you're all developers. I assume that when I tell you it's out, you understand it doesn't necessarily mean it's going to work, right? Oh.
The right